Good day everyone. I'm Romar O. Chavez, student of Bachelor of Science in Mechanical Engineering, and I am here to report to you about my topic in the subject course Manufacturing Processes and System, which is the beer making process. Richard Feynman once said, all life is fermentation, meaning all things that keep us alive and give us energy are using very unique chemistry. And this came from billion years Earth's original fermenter. We have bacteria and yeast. Evolutionary experience to work to produce a magical liquid. And that magical liquid is beer. Now, the big question is, what is beer? Beer is any alcoholic beverages made from fermented cereal grains, usually preserved and flavored with hops. Grains like barley or wheat are malted, steeped, germinated, and dried, soaked in hot water to release their sugars, greener liquid called wort. Flavorings are added when wort is cooled, and then yeast is begin the conversion of sugar to ethanol and CO2.
And now, let's begin to my presentation. As discussed earlier, the beer is an alcoholic beverages produced by fermentation of sugar-rich extracts derived from cereal grains or other starchy material. And the beer has barley, yeast, hops, water, and adjuncts. And now, let's discuss it one by one. We have the barley, the body and soul of the beer. Natural enzymes to convert starch to sugar needed for fermentation. Malty, sweet flavor. The color. 2 raw and raw barley malt are used, and it is also responsible for the foamy head. Next one, we have the yeast, the life of the beer. Yeast is a catalyst of change, one-cell microorganism, produces carbon dioxide and alcohol. It is a small animal which zips sugar through its snout and excretes alcohol from its gut and carbonic acid from its urinary organ. Now let's proceed to type of brewing yeast. 2 types of brewing yeast, originally classified on flocculation behavior. We have the first one, the top fermenting, which means they can ferment at higher temperature and ultimately produce esters, an organic compound easily described as fats and oils. We have 2 examples for this, the alley yeast and the Weiss yeast. Also, we have bottom fermenting, which means they can ferment at lower temperature, producing a crispier taste. The great example for this is the lager yeast. We have also wild yeast, which are very seldom to use in brewing process, but when they are, they produce an extra compounds that are more acidic and acquire taste. These are rarely used because the extract flavor profile is harder to control from a brewing perspective. And now let's proceed for the factor of yeast. Alley and Weiss yeast is Saccharomyces cerevisiae only, while lager yeast are Saccharomyces pastorianus, Saccharomyces cerevisiae, Saccharomyces heidelbergensis, and Saccharomyces overum. The identity of Saccharomyces overum is lighter golden beer with a sweet hint and medium amounts of hops. They can also perform their duty at 15 degrees Celsius for 2 weeks. And for Saccharomyces cerevisiae, its identity is darker beer, has a darker roasted malted grains that gives the color and light roasted malts to provide sugar for fermentation. It can also perform its duty at 18 degrees Celsius for 2 to 3 weeks. Next, we have the hops, the spice of beer. Hop flowers are used to microbial stabilization. Hops have antiseptic qualities. Hop aroma, fruity flowery characteristics. bitterness, balance malt sweetness. There are two primary hop styles. We have the aroma hops and bitter hops. The aroma hops, zest, fungal, and halertua, while the bitter hops, brewers, gold, and unique.
Hops are the flowers of the hop plants, which are used for flavorings. The only other uses for hops are in herbal medicine.
Without hops, we would have a hard time tasting the flavor and ultimately enjoy the beer. Next, we have the water, the integrity and purity of the beer. Water's role in beer. Water makes up 92% of beer. Water styles can affect flavor. Hard water helps add crisp and cleanness, while soft water adds softness.
In addition, mineral content in the water source can make a huge difference to the type of beer that we'll brew. Calcium and magnesium, otherwise referred to its hardness effects of the yeast, grow and stabilizes the sugar in the brew. Bicarbonate HCO3 in the water also affects the pH of the beer during the fermentation process.
And last but not the least, the adjuncts, which is the wild card of the beer. Adjuncts add to the beer falls into two categories. We have grains, which is classified as corn, rice, wheat, oats, or rye. While on the other hand, we have specialty ingredients. We have the sweets, the honey or maple, the fruits, the raspberry, cherry, or cranberry. The spices, we have cinnamon, coriander, or clove.
The next video would tell us some information regarding beer making process.
Luckily, I'm here at Jester King Brewery in Austin, Texas today with Avery Swanson. You think you can show us how it's done?
I think I probably could give you some insight into all that.
Let's take a little brewing science tour. So, what's different about the kind of beer you make here compared to sort of the typical mass-produced beers that people might be used to?
The basic idea is that we are a farmhouse brewery. We're trying to create a product that has a sense of place, a reflection of this time and space and the people making it. We like to think that if you were to take the exact same ingredients and the exact same recipe and try to replicate our product somewhere else, it would taste completely different.
What are you trying to make in your final product? How much do you guide the process and how much do you sort of leave up to nature?
In our final product, we're looking for as many different interesting flavor and aroma profiles as possible. We don't use lab-cultivated single strains of yeast. We really feel like the use of a mixed culture that has many different organisms in it that are all doing totally different things really provides a more interesting aroma and flavor profile to our beer.
A melting pot of kind of different organisms.
Really?
Where do those different organisms come from? So I know it's like sometimes you put things like fruit into your beers.
So there's yeast and bacteria everywhere around us. It's on your clothes and your skin, it's in the air, it's on the fruit, the produce that you buy at the grocery store. So we can actually take that fruit, put it into live beer or beer that has living microorganisms in it, and those organisms will work together to undergo another fermentation. Each barrel is a completely different microcosm and its own completely unique microbial population.
So what kind of little bugs are in this barrel that are working on the beer right now?
So mostly Saccharomyces cerevisiae, which is your typical brewer's yeast, but we do also use Brettanomyces, which is a wild yeast. There's also souring bacteria present in these barrels, Lactobacillus pediococcus, multiple species of each of these different organisms.
This sort of feels like you're doing tiny evolution experiments. What do you think is happening in here in terms of those genetics?
They reproduce so quickly, and so the mutation rate is very, very high, and they have to be taking up some of the same genetic material that's present in the other organisms that are living within the barrel. It offers us an opportunity to work with new organisms that are going to be able to produce new compounds, new aromas, new flavors in the final product.
You never know what they're going to bring to the table.
No, that's the exciting part.
And finally, let's proceed to the brewing process. We have the first one, the milling process. The milling process involves splitting the barley husk and grinding the starchy endosperm into small particles. The husk can be used to form the filter bed during the wort separation. The endosperm must be broken down to allow the enzymes action during the mashing. The mashing process. The temperature determines how the sugar are broken down in the mash that will dictate to the yeast to eat. Or in simple term, it is a broken down of complex sugar into simpler form. Next, the lautering process. It is separating the crushed grain from the sweet liquid, the rot, that later on will become beer. After which, we have the wort boiling. It is clear sugar liquid that is collected during runoff, also called sweet wort. And it is collected in boiled kettle or just kettle.
All ingredients are boiled together at the set amount of time until the final mixture is filtered and sent to fermentation.
The fermentation or the pitching process. The addition of yeast to the cold wort, also bitter wort now. The main player to this process is yeast. Yeast is the most important element to make the beer alcoholic and carbonated during the fermentation process. The next process is filtration. The beer is typically filtered immediately before packing. Filtering removes all yeast and other microorganisms, can also remove proteins and other large molecules. And lastly, the final stage of brewing process, the bottling or packaging. Beer bottling process. Packing of bottled beer typically involves drawing the product from a holding tank and filling it into bottles in a filling machine or the filler, which are then capped, labeled, and packed into cases or boxes. A few beer are bottled with a cork or cage. And that ends my presentation.